Hello, hi everyone. Welcome to the Student Brand. So today we are going to discuss about CBSE Grade-11 vectors topic. Vectors, vectors. So vectors, right? So normally, what is quantity? Quantity. Quantity is nothing but if you are going to shop and ask shopkeeper, so I want 1 kg rice, I want to 2 kg like that. So if you are asking anything, okay, so immediately, so I want rice. If you ask rice, immediately will ask two questions: how many kgs you want, or and for how much you want. Okay, so how many kgs and for how much? For how much you want? Like this, like this. So like this they will ask. Like this they will ask, right? Yes. So the question is, if you are going to shop and ask, I want rice, I want dal, I want so something. So immediately we'll ask two questions: for how much you want, or how many kgs you want. So that is the quantity, nothing but it tells the answer for how much or how many. It tells the answer for how much or how many. How much or how many. So how much or how many, that is called quantity. Okay, it tells the answer for how much or how many. And physical quantity. So physical quantity. So first one is quantity. Okay, so quantity I'm taking. Quantity is nothing but it tells the answer for how much or how many. How much or how many. Okay. Next one, physical quantity. Physical quantity. So what is physical quantity? Physical quantity. Physical quantity. Okay. Physical quantity is nothing but the quantity which can be measurable. The quantity which can be measurable is called physical quantity. The quantity which can be measurable is called physical quantity. The quantity which can be measurable, the quantity which can be measurable is called physical quantity. Physical quantity. Okay. Best example: mass, volume, mass, volume. Okay, and you can say density, distance, displacement, velocity, acceleration. So these are all we can measure, right? That's why physical quantity, that's why it is called physical quantity. The quantity which can be measurable, the quantity which can be measurable is called physical quantity. So quantity already said. So physical quantity means it tells the answer for how much or how many. It tells the answer for how much or how many. So physical quantity means the quantity which can be measurable. The quantity which can be measurable. The quantity which can be measurable is called physical quantity. Physical quantity. So already I said example. Example one is mass, volume, density, acceleration, speed, velocity, momentum, angular momentum. Like that, there are many. Are there. So right now we are discussing about quantity, physical quantity. Next one, physical quantities. Physical quantities are divided remaining. So we will, for today we'll concentrate on vectors and scalars. Completely we'll discuss about scalars and vectors. Okay. So scalars, coming to scalars. Okay, so coming to scalar. So what is scalar? The physical quantity which have only magnitude. The physical quantity which has only magnitude. The physical quantity which has only magnitude, that is called scalar. Example, first one I am taking the mass. Okay, and the second one is speed. Okay, speed, mass, speed, and the third one is density. Okay, so density, like this if you are taking. So this has only magnitude, only magnitude. Understood? So scalar, mass is only 2 kg, 3 kg. Volume also we can take. Volume also we can consider volume. These are the physical quantities. These are physical quantity. That too scalar quantity. Scalar quantity. Okay. Scalar quantity. One is, so mass is a scalar quantity, speed is a scalar quantity, density is a scalar quantity, volume is a scalar quantity. Next one, coming to the one more. Okay, so yes, we can take many more. So etc. we can consider. So only I said few. Like I given only few examples. We can take remaining also. That is about scalar. Coming to the vectors, the quantity which has both magnitude and direction, the quantity which has both magnitude and direction, that is called vector. Okay, so vector. So coming to vectors, we'll discuss about vectors. Vectors. Vectors are nothing but vectors. The physical quantity which has both magnitude and direction. The physical quantity which has both magnitude and direction. So that is called a vector. Vector example. So velocity. Okay, displacement. Anyway, displacement we can take displacement. And coming to the third one, acceleration. Okay, so the physical quantity which has both magnitude and direction, so that is called vectors. So that is called vector. Velocity is a vector, displacement is a vector, acceleration is a vector, because it has magnitude as well as direction, magnitude as well as direction also. Okay, so sir, we can tell only magnitude and direction is sufficient for explaining the vector? No, so it should follow the parallelogram. Okay, vector law of addition. So that we will discuss about it. Okay, so this is about vectors. Coming to the vectors and scalars. Now types of vectors we'll discuss. Types of vectors. Types of vector. Equal vector. First one is vector types. Types of vectors. Okay, first one equal vector. Equal vectors. Second one negative vectors. Third one is zero vector or null vector. Null vector. And fourth one is unit vector. And fifth one co-initial vector. And sixth one co-terminal vectors. Okay, so seventh one, once again, whatever we are discussing, just check it once. Collinear vector, coplanar vectors. Next one is collinear vector. And eighth one coplanar vector. Localized vector, non-localized vector is there. Localized vector, non-localized vector. So like that. So we can take, first we will discuss about these points. Equal vector. Equal vectors are nothing but equal vector. First one, equal vectors are nothing but, so both magnitude and direction is same. Both the vector whose the vectors having both magnitude and direction. The vectors having both magnitude and direction. Okay, so same magnitude. So the vectors having both. Okay, so both vectors having same magnitude and direction. Both vectors having same magnitude and direction. Same magnitude and direction is called. So vectors having two vectors having same magnitude and direction, those are called equal vector. Coming to the negative vectors, so same magnitude but opposite direction. Same magnitude but opposite direction. Coming to third one, zero vector or null vector. The vector whose magnitude is zero. The vector whose magnitude is zero. So the vector whose magnitude is zero, that is called zero vector or null vector. Zero vector or null vector. Coming to the fourth one, unit vector. Unit vector is nothing but the vector whose magnitude is the vector whose magnitude is 1 unit. The vector whose magnitude is 1 unit. The vector whose magnitude is 1 unit, that is called unit vector. Unit vector. Unit vector can be represented normally. So vector can be represented. So capital letters A bar we are representing because magnitude as well as direction is there. Magnitude as well as direction is there. So unit vector, if you want to represent unit vector, so we can represent with cap A cap. A cap equal to A bar by mod A bar. Mod A bar. So how we can take? So unit vector A cap equal to A bar by mod A bar. Mod A bar. So now normally if you are taking, suppose I am considering A bar is a vector. A bar is a vector. 2I cap 3j cap plus 4k cap. So this is the vector. So I cap, j cap, k cap are orthogonal vector along x axis, y axis. Okay, so you can take x axis, along the x axis I cap, along x axis I cap, along y axis j cap, along z axis k cap. These are the unit vectors. I cap is x axis, j cap along y axis, k cap along z axis. So these are the unit vectors. Unit vectors along x axis I cap, along y axis j cap, along z axis is k cap. So these are the unit vectors along x axis, y axis, z axis. So that's why I am taking here. So 2I cap, 3j cap, 4k cap. Okay, if I want to find the magnitude of this vector, so if I want to find out the magnitude of this vector, magnitude of A bar equal to root over 2 square plus 3 square plus 4 square. That is nothing but, so 2 square is 4, 3 square is 9, so 4 square is 16. Then root over 29. So 16 plus 4, 20 plus 29. Okay, so this is about unit vector magnitude. How to find out the vector magnitude? So this is the vector I am taking. A bar equal to 2I cap plus 3j cap plus 4k cap mod of the. Okay, so to find the magnitude, if you want to find the magnitude of the vector, if you want to find out the magnitude of the vector, mod A bar equal to root over 2 square plus 3 square plus 4 square. Root over 2 square is 4, 3 square is 9, 4 square is 16. So 16 plus 4 is 10. Sorry, 20. 16 plus 4 is 20 plus 9, 29. So I am taking A bar is the magnitude of A bar. So if I want to write A cap, if you want to write A cap equal to, so A bar I am taking 2I cap plus 3j cap plus 4k cap. Okay, by root over 29. So this is the unit vector. Okay, so this is the unit vector. So to find the unit vector of the, so Along the unit vector direction also along a bar only, along a bar only. So along a bar only we will take. So that is unit vector. So this is the way to find the unit vector. Okay. So I hope it is very clear to you all. Next one. Next one you can see. So that is a so unit vector. Coming to initial vector, co-initial vector. So normally vector is initial point is this one. This is the initial point and this is the final point. Okay. So head tail. So head and tail also we can take this head and tail we can consider co-initial vector. So all initial point is at one point. So our initial point, all initial point are at one point. So that is about co-initial vector. Coming to the co-terminal vectors. Coming to the co-terminal vectors. All terminal points at one point. So I am taking here all terminal points. Okay, co-terminal vectors. And coming to the collinear vectors, if you are taking collinear vectors are nothing but so the vectors are in the same direction. Okay, along the so acting in the same direction or same line. So that is called collinear vectors. Coming to the coplanar vectors. So we can take x-axis, y-axis, and z-axis x-axis, x-axis, y-axis and z-axis. So I am taking this one plane and this is the one plane like that if you are taking. So the vectors acting in the same plane, that is called coplanar vectors. And one more is localized vector, the vector whose initial point is fixed, that is called localized vector. Non-localized vector, the vector whose initial point is not fixed, non-localized vector. Okay, so these are the vectors. Next one, position vectors also there, position vector. So I am taking to represent any object, I am taking x-axis and y-axis. So this is the position of the object. If you want to represent all initial points at one point, co-initial vector means all initial point is at one point. So I am taking here on initial points. So I am taking this vector a bar, b bar and c bar. All initial point will be at one point. So that is co-initial vector. Co-terminal vectors, all terminal points. So all terminal points, end point we are taking. Collinear vector, all vectors are acting in the same line. And coming to the coplanar vectors, vector acting in the same plane, vectors acting in the same plane. Coming to the position vector to represent position of an object with coordinate axis, x-axis, y-axis. So we are taking the position vector r bar. So the starting from the origin. Okay. So this is about types of vectors: equal vector, negative vector, zero vector, unit vector, co-initial vector, co-terminal vector, collinear vector, coplanar vectors. I hope it is very clear to you all. Okay, so once look at the board, check once. So how to find out the unit vector. So everything will get to know. Okay, check once. These are the types of vector. Okay, so take some time and observe the board. Okay, so this is about the types of vectors. Okay, so position vector, if you want to represent of an object, so object is placed with the help of x-axis, y-axis. From the region we are representing the position of the vector. Okay, so this is about types of vectors. Next we will discuss about addition of vectors. So here there are three types are there. One is triangle of vectors, parallelogram vectors, polygon of vectors. So parallelogram I will explain. So triangle of vectors, polygon of vectors. Next you see addition of vectors, addition of vectors, addition of vectors. Normally, so like scalars we can't add. So 2 plus 3, 3 plus 4, 5 plus 6, 7 plus 8, like that we can't add vectors. So vectors, if you are taking a bar, so a bar equal to 2i cap, 3j cap, 4k cap, like that I am taking. So if they give vector, so normally, so there is a three ways, okay, three addition of vector, there are three ways. One is triangle of vectors, 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 and the second one is parallelogram vectors. Parallelogram vectors, parallelogram vectors. Okay, so one is addition of vectors, parallelogram vectors, parallelogram vectors. And the third one, polygon law vectors, polygon law vectors. So we'll discuss about triangle law vector. Triangle law vector is nothing but triangle of vectors. If I am taking the two vectors, so I am taking a bar is along this one and b bar along this one. Okay, so two vectors I am taking. The third side of the vector is in the, so that will be reverse of the, or in order that, so opposite of these two vectors, opposite of these two vectors, opposite. So a bar and b bar are two, this a bar and b bar vectors are in the acting in the same direction. The resultant of the vector will be opposite to of that. So that is c bar. So now I am taking the resultant. C bar is equal to a bar plus b bar, a bar plus b bar. So this is about resultant. So I'll give one diagram, try to identify. I'll give one diagram, try to identify. Okay. So in this, what is the resultant? Resultant vector. Can you identify the resultant vector? Resultant vector. Which one is the resultant vector? Anyone? Resultant vector. Resultant vector. Very good, very good. N is the N. So N bar is the resultant vector because two vectors are acting the same direction. N bar is N bar. Okay, N bar is acting opposite of that. Okay, that's why N bar is the resultant vector. So here you see this is acting in this direction, this is acting in the direction. So this N bar is acting opposite of those two vectors. So that's why you have to take the resultant. Resultant must be opposite of remaining two vectors. One more example I'll give. Try to do it. So same thing like that only we will consider, same like that only. So even polygon law vector also same. Polygon law vector also same. Polygon law vector also same. So polygon, so we are taking so many sides in one direction. The resultant will be opposite of all those vectors. That's enough. So triangular vector I am taking. So two sides along the sides of the triangle. Okay, so like this. I'll draw one diagram. Try to identify. Okay. So In first triangle, in first triangle, in first triangle, in first triangle, so what is the resultant? In second triangle, what is the resultant? In third triangle, what is the resultant? Can you tell? Can you identify? In first triangle, what is the resultant? Second triangle, what is the resultant? Third triangle, what is the resultant? Identify, one check it. So arrow mark I kept over here. So you can follow this arrow mark. You can follow this arrow mark. Okay, so actually at the corners if I'm placing, so you're getting confusion. That's why just to follow that. Just to follow that arrow mark. That's enough. So in first vector, first triangle, what is the resultant? In second triangle, what is the resultant? Third triangle, what is the resultant? Can you identify? B E B. No, can you try once again? Okay, when you are seeing this triangle, you have to take it. First triangle, you have to take only A, B, C, D vectors. When you are seeing that second triangle, you have to take C, D, E. When you are taking the third triangle, you have to consider E, E bar, F bar and K bar. Okay. So among this one, which one is the resultant? Can you identify? Yes, is class for class 12. This is for class 12, not class 10. This is for class 12. CBSE grade 12 physics. CBSE grade 12, grade 11. Grade 11 also will get grade 12 ka. So those are studying grade 12 and JEE NEET also they can attend. Grade 11 especially, grade 11. Okay, check once. Here, in this case, once observe. So once observe the first triangle. First triangle. So this is one direction, and this one is in this direction, and this one. Okay. So here along this one, and along this one. So these two vectors are in the same direction. So B bar is in opposite direction. A bar. So C bar. C bar, A bar in the same direction, only B bar is in opposite direction. So B bar is the resultant. And here in this case, so second triangle, coming to the second triangle. So E bar is acting in this direction and D bar is acting in this direction. So C bar is opposite to of that. So here D bar and here E bar and C bar. C bar is the resultant. C bar is the resultant. Coming to the third one. Third one you can observe. This is a triangle. F bar is acting F bar and so E bar is acting here and K bar is acting like this. Okay. Now you can see which one is the resultant. So KE acting same direction, but F bar is acting opposite direction. F bar. Check once any changes are there or not. Okay, so that's enough. That is about triangle of vectors. Triangle of vectors. So next one, polygon of vector, also same thing. So if you are taking all sides are in one direction, the resultant of the polygon will be opposite of. Okay, so resultant will be you are taking in this direction, opposite. So A bar, B bar, C bar, D bar, E bar, and F bar is the resultant. So polygon law vector I am taking. Polygon law vectors. So polygon law vectors along all direction, along in the same direction, all vectors we are taking the same direction. The resultant will be opposite of that remaining vector. So that's why. So F bar is the resultant. That is about polygon law vector. Is it clear? Next one. So we will discuss about parallelogram vectors. So parallelogram vectors will discuss. So two sides are taking along the sides of parallelogram. Two vectors are taking in order that along the two sides of the parallelogram. Okay. Now parallelogram vectors. Parallelogram law of vectors. So I am taking two vectors along the two sides of parallelogram. So I am taking like this. A bar and B bar. So in parallelogram two sides are equal. So I am taking here. So A bar and this one is the B bar. So this is a resultant. Bar. So actually A bar and B bar both are placed with certain angle theta. So A bar and B bar. So if you are considering here, so normally if you are taking x-axis and y-axis, this is the x-axis y-axis. Okay, so I'm taking this also theta here, this is x and y. So from this one, from this triangle, right angle triangle, if you are taking this triangle, this is theta, x and y. So this is b bar I am taking here. Okay, if you are taking magnitude is b. So what is the cos theta formula? Cos theta formula, adjacent side by hypotenuse. Adjacent side is x by b I am taking. So x equal to b cos theta. B cos theta. So now, what is sin theta formula? Sin theta formula is opposite side by hypotenuse. That is y equal to b sin theta. Y equal to b sin theta. Y equal to b sin theta. X equal to b cos theta. Now, if you are taking this total right angle triangle, I am considering this a total right angle triangle. Resultant, if you are considering. Resultant I am considering resultant r square equal to, so a plus x whole square, a plus x whole square plus, so we are taking what, y square. Okay, now you are taking r square equal to a square plus, so x square plus 2ax plus y square. Y square is nothing but b cos theta. Y square is nothing but b cos theta. R square equal to a square plus x value is what? X value is b cos theta. X value is b cos theta whole square plus 2a into x is nothing but b cos theta. B cos theta plus y square is nothing but b sin theta whole square. B sin theta whole square I am taking now. R square equal to a square plus b square cos theta. A square plus b square cos theta. B square cos theta plus 2ab cos theta plus b square sin square theta. B square sin square theta. Now I am considering here. So now you can take common. So among these two I am taking these two. In these two, we can take b square common. So b square we can take common. Now r square equal to a square plus b square sin square theta plus cos square theta. Okay. So here I am taking cos square theta plus sin square theta also same only, right? So write like that only. So cos square theta plus sin square theta equal to plus 2ab cos theta. Now r square equal to a square plus sin square theta plus cos square theta equal to. Okay, so what is the formula? Sin square theta plus cos square theta equal to 1. Okay, sin square theta plus cos square theta equal to 1. So b square I am taking plus 2ab cos theta. So this is about formula. So do you agree with that? One check once. Two vectors are taking along the two sides of the parallelogram, a bar and b bar. The resultant is r bar. So I am taking, so we are extending x. This is y. Okay, so this is parallel to y axis and this is parallel to x axis. That's why angle between these theta I am taking. So now you can take cos theta. From this triangle, cos theta equal to, so adjacent side by hypotenuse, x by b. So x equal to b cos theta. Sin theta is nothing but opposite side by hypotenuse. Sin theta equal to y by b. Y equal to b sin theta. So from that, if you want to find out the resultant formula is r square equal to a plus. So we are taking the magnitude only. So a plus x whole square plus y square. R square equal to A square plus X square plus 2AX plus Y square. R square equal to A square plus. So here X value is B cos theta. Substitute B cos theta. So B cos theta whole square plus 2AB cos theta plus. So Y square. So Y square nothing but B sin theta. Y square is nothing but B sin theta. So B sin theta you can substitute whole square. R square plus A square plus B cos square theta plus 2AB cos theta plus B square sin square theta. So we know sin square theta plus cos square theta equal to 1. Sin square theta plus cos square theta 1. Okay. So we know that sin square theta plus cos square theta equal to 1. That's why R square equal to A square plus B square plus 2AB cos theta. 2AB cos theta. Okay, I hope it is very clear to you all. Next one, so this is about addition of vectors. Addition of vectors. Clear? Do you have any doubts? Do you have any doubts in this? So we can also take R equal to root over A square plus B square plus 2AB cos theta. 2AB cos theta. We can take like this. Okay, done. So now I'll give one question. So try to do it. So related to our parallelogram vectors. Related to parallelogram vectors, I'll give few questions. Try to do it. Okay, so can you identify if theta is 0 and if theta is 90, so what is the resultant? What is the resultant? Okay, so I'm giving for homework. I'm giving for homework. Try to do it and let me know in the comment section. So thank you so much for joining and attending my class and listening to the class and giving an opportunity to take class. So thank you so much. This is Shiva sir from Student Brand. So if you like this video, please do like, share and subscribe to Student Brand. If you like the content, you can inform your friends, ask them to join to the class. Thank you so much.